Hi all, welcome to the next edition of Amnic Cast. And before we begin, wish you all a very happy New Year. And then we have Sreedhar Gade, who is a vice president at Freshworks. As usual, I want to give the disclaimer over here that our panelists will be sharing their personal opinions, knowledge, and expertise in their respective field. Again, all their views are their personal and their own stuff, and it do not represent any of their official positions or policies or endorsements of the companies they work for. All the discussion here is intended to reflect their individual experience and insights. Right. With that, let me introduce Sridhar. Again, Sridhar has 2 decades of experience, and I have had a long association with him. About a decade back, both of us worked at Yahoo in the same organization. Welcome, Sridhar, to the Amnic Cast.
Thank you, Satya.
Awesome. So let's start with your own journey, right? Like I have had a brief stuff with you at Yahoo, which was a very different world to where today it's all more like a cloud and then Gen AI, right? So why don't you take us through your journey from where you started off, how you transitioned into distributed computing to where things are here, right?
No, absolutely. First of all, thanks Amnic and Satya for having me here. There's no better way to start this year than talking about generative AI, which is my favorite subject. So to start with, it's been a couple of decades. Just time kind of flies. But then, essentially, I went through or I witnessed personally three different major transition periods in the world of computing technology. The first one is transition from a centralized computing to distributed computing. So when I first started my career really long ago, early 2000s, I still remember working on HP Superdome servers, high-end Sun Solaris, and also mainframe machines. Where today mainframes are kind of limited to some of the very few large banking sector organizations, but it was kind of a commonplace at that time where all the computing in the centralized in one very gigantic machine. Sometimes it's the whole room or the entire hall was filled with that one single machine, and then it is actually connected to hundreds and thousands of so-called dumb terminals, which are only input-output devices, where the 100% of processing happens at the centrally, but then the I/O kind of goes to the keyboard and the monitors of the end users. From here, uh, the world kind of completely changed with the invention or the takeover of Linux, and then the BSD and CentOS and all the commodity OS and the hardware kind of took over the world. And then during my tenure at Yahoo, the experience of working with server farms, where each farm had up to 30,000 to 50,000 machines, commodity hardware kind of stacked and worked as a single unit. uh, Under the hood, it's a distributed computing. Again, backbone is connected with the fiber optics and the high speed copper, but then they are all like individual machines working as a single unit to do it. So this is one phase of transition that I've seen. Second phase was the distributed, what I just spoke, computing using Hadoop clusters to proper cloud. So this happened somewhere between 2007 to 2012, this 5 year period where AWS and Microsoft they started building these hyperplanes where, hey, companies are individually inventing, building their own private clouds. And how about we actually build a public cloud where everyone can actually piggyback, so that all the invention can kind of stay in one place. So it just took off so fast. I remember my tenure at Microsoft, where we were actually building these cloud data centers. I was part of the Azure, early Azure in 2012, where we were actually talking about container data centers, where each container had up to 30,000 machines. Again, like wired together, work like a single unit. But the best part is the customers. All they needed was a just laptop with internet connection. All the storage compute network is kind of available for them. And today we all know that, like, where it is in terms of the cloud computing, with now large players like we have AWS, we have Azure, GCP, and then we also have Oracle OCP, and Ali Cloud and stuff like that. So that was the second major transition that I've witnessed. The third one is the cloud to generative AI. It's less of a transition, more of a kind of a transformation. Is where cloud gave traditional compute and traditional services for us to actually build, take a company from a startup to enterprise. Whereas the generative AI is actually putting the same thing in an exponential scale, right? Where whether you are working on building new products with code, where you're working on actually taking your customer service to the next level, building bots, or even the plain old the website building, everything is kind of automated and taken to the totally next level with the generative AI coming in. We are all aware, ML, traditional ML and AI has been around for many years. But then actual generative AI, we started talking about it since 2017 and 18. We personally in this company, also in the previous companies, experimented with GPT 1 and 2 versions, but then it became more prominent, popular after GPT 3.5 early this year, or I think late last year. Last year, when I meant like 2022 Q4, right? And then 2023 Q1, and then people started realizing it. So these are the three major transformations, Satya, so to speak. So I've been fortunate to be witnessing all these three during my career, and looking forward to more, great inventions like artificial general intelligence, artificial super intelligence that are coming in next 7 to 10 years. You'll find more such stuff in my LinkedIn blogs, but super excited about what's coming.
I think it's an amazing journey, and you gave a brief history and time in terms of how the whole computer itself evolved from where it was to where it is today, right? And then, so I was talking to Sreedhar in terms of how do we do this Gen AI stuff, because he has so much of information in terms of how do we take a Gen AI from its concept to productionizing it, and then we felt like it can't be done in a single part series, right? And that's where we have divided into three parts. I would like Sridhar himself to talk about like how are we thinking about these three-part series.
Absolutely. So it's a complex the scenario, and then it's becoming complex as we speak. Every single day we have new models, new companies coming up with the AI powered systems. So what we thought was, hey, instead of actually talking about in one, which is probably very high level, we talk about three series. The first series is the current one, what we are speaking today, which is about how do we take the generative AI, bootstrap your company from zero generative AI to some use cases generative AI in production, and what are the practical nuances that you will go through if you are an SMB and mid market or enterprise company, and what I faced personally, and what you should do to solve some of those problems. So that is the first episode, which is right now being live aired. The second episode is about when we scale. The scenario totally changes. The first few 1 or 2 quarters of implementing generative AI in production and doing it more than a year, completely different ballgame altogether. So what are the practical nuances there? What kind of people, process, technology, building generative AI teams, how do you actually build and hire data scientists, and many other the practical nuances of scaling at an enterprise level is actually second episode. uh, and the third episode is very important, is about generative AI, responsible AI, which means how do we protect customer data, how do we bring in safety into your platform, and then protect your customer IP and your company's IP, and make sure that things that can go wrong with generative AI are not impacting your organization. So these are the three-part series that we are planning, Satya.
Thanks, Sridhar. I think I think hopefully everybody will know that it covers an end-to-end landscape, right? From in terms of conceptualizing what use cases to take to how do you actually scale it, put it into production, what are some of the nuances that you would have to handle, to once you are in production, when somebody is asking questions like what are the governance framework that you will have to do, right? So with that, let's get into the first one. So what are some of the use cases that you see, right? A lot of generative AI, pretty much anything you touch today, they are experimenting. There are certain things that are happening. Different kinds of industries taking this into productionizing the whole stuff, right?
No, absolutely. I'll talk about use cases, and before that, I also talk about a little bit of a different approaches that each segment of industry folks are doing. So, if I talk about startups and SMBs who are still finding their feet in the industry and focusing more on their business use cases and building the product to put out in the market, for them, generative AI is like I think it's a very gigantic project to take on. While it will improve overall customer experience, at the same time, adoption is very complex. So what they are doing is actually picking back on large players who are actually giving full stack, ready to use models with almost no model level innovation, and the innovation is happening only at the use case level.
Yeah.
That's at the startups and SMBs, and it's rightfully so because with the limited resources that they have, very few things I think they can accomplish, and that those few things probably is centered around building the use cases itself. And when you talk about mid market is actually doing a little bit of building that use cases, but at the same time they're also building a little bit of a tuning of the models to actually fit their industry vertical needs. So we're talking about companies which are actually building IDSM verticalization, folks are building support or CRM, pharmaceuticals and various different one, but very limited tuning. And third one is enterprise customer, enterprise companies like a ServiceNow, Salesforce, and all these large companies are actually going to totally proprietary models, industry vertical models, where they are building the huge data scientist team, also GPU inventory, so that they are actually working for a longer term view. These are the three different. But quickly talking about use cases, Satya, there are simple to complex use cases. Simple use cases where we are actually not looking for any customized models. Very generic models is um, content summarization, article generation, generating test cases, from a given a particular scenario, and email generation. So sentiment analysis. So these are all basic use cases of any generic LLM. So you basically use any GPT based or Falcon, right? So most of the or Bard, right? Most of the generic LLMs are able to give these functionalities.
Yeah.
And as we
So,
become more and more, sorry, go ahead.
no, go ahead, go ahead, go ahead. Sorry. Go ahead.
Yeah, so that's the entry level. But then as we become a little more complex, now we are talking about building code, learning from your code base and actually giving you actually libraries and code bases, build bots and build more complex the chat bots, which can actually interact with your customers and automate some of your flows. And this is somewhere in the middle of the spectrum. And if you go to the far end, now you're talking about sophisticated the medical based models where they can actually go through all your medical reports, your MRI reports, and be able to actually predict what's happening. Analyze your blood samples, and even predict your possibility of actually getting a cancer. This is the other end of the spectrum. So this is the whole gambit of things that are being developed as we speak.
Awesome. Now, to just get a little bit into it, right? Let's say I have a use case, and then there is a different stages of it, right? Like you talked about multiple use cases. Now you start with prototyping, and then you probably experiment it, right? What is the journey to take everything into production, right? How do you conceptualize, and what is the life cycle towards the productionizing the model itself?
Yeah, no, I think this is it's completely different, and from the traditional way of building SaaS products. So if I want to compare it, like traditionally, you have a use case in mind. I need to build this functionality for my
Mhm.
user. Say the functionality is the basket for e-commerce portal, right? So then I have a pipeline, CI/CD pipeline, where I have a development, I have test, right, and then a pre-prod and production, and the same code keeps going from one place to other place, but it's exactly same functionality flowing through with the minor changes and then improvements. And then at some point you decide that this is production viable code and I want to implement it,
Yep.
right? In case of generative AI, you have totally different set of when we're actually building this use case. In the beginning we don't know which model is going to actually cut it, which
Yep.
model is going to actually help us actually develop the use case that we are looking at. So which means to me it looks like more like a funnel where uh, in the development phase I might be using 10 different models, some commercial, some free, right, and letting me experiment with feeding my use cases to be able to benchmark. And in the test phase, I'll be kind of finalizing that 10 models to maybe 3 or 4, and by the time I get to production I'll have one model. right? And it's important because once you get to production, now you already put it out for the end users to use, and it's very difficult for you to pull it back. It does happen, right, in for some of the use cases I've seen in the production, but we want to minimize that. For us to be able to do it, we want to look at, is the model giving the functionality I need? Is the model giving the cost benefit I need? Is it hallucinating? Is the performance is good enough? All these things we need to figure out early in the game, and so as a funnel, as you go, you kind of shortlist the number of models that are going in. So I think that is a CI/CD pipeline that we need to build.
Awesome. And when you do these funneling, right, and then you check, you have 10 models initially, then you make it to 3, right? How do you actually check like
Satya, could you repeat that? I think missed
so
part of the.
what I'm saying is like when you have this funnel, right, and then you have 10 models and then you are making it to one, what kind of measurement you do to come up to that one model that you say that, hey, it's not
Yeah.
hallucinating, this is the better one.
Yeah. So even before a hallucination, I think it's more complex measure to measure. But some of the things that we want to look at it is for the output that we are generating, how many tokens am I consuming
Mhm.
at an average? Okay, and then tokens will directly translate to the cost. That's the number
Correct.
one measure.
Yep. Yep.
Okay.
Yep.
So, and then, I try to loosely kind of estimate, hey, will there be an ROI? Will I be able to monetize it? That's number one. Number two, then I have a certain limits on round trips. So, imagine a case where the use case is about this automated bot reading through 4 different articles of ITSM articles and then summarizing into 4 lines. If each article is running into 1,000 lines, so I'm talking about inputting maybe 100,000 tokens to my LLM.
Yep.
By any
Yep.
means, LLM is going to take probably like 20 seconds to probably 2 minutes to even come back.
Yep. Yep. Yep.
So that will make me unviable. So I need to actually tune my use case, and so that is about performance. So we look at performance, we look at cost, we look at accuracy. Like, are we getting actually the output? So accuracy needs human oversight, and then especially for bias and hallucination, we have inbuilt systems either by Microsoft or AWS. It kind of early in the game they try to detect it and flag it. But yeah, these are all the different parameters that we look at before we say, hey, this is good enough for us to actually productionize.
I think that's a very very important point, right? See, because one, you have a use case and then you run a model. I think what is the time it takes to actually process and come back? Will the user wait for it, and the cost for it? It's a very important metric because you could build an amazingly accurate stuff, but if it's going to cost you a fortune to actually get it, it's not going to work, right? In real life production, that's where the prototype stops. You can actually do an amazing demo, but it will never go live, right? Versus, I think the right stuff, like as you pointed out, is to actually look at the cost, look at like performance, and to be able to do it, right? In doing that, what are some of the challenges that you have faced? Now you have been doing this and you're taking it to production. Like, what are some of
Yeah.
the operating challenges that you have faced, and how did you overcome those things?
Yeah. No, there were many, but I think just to kind of categorize some of them, one is the choosing of the right model and right cloud provider. And so certain things that I've seen, my observation in the industry, plus in the some of the scenarios that I'm currently executing is once we deployed it in the production, we started realizing is that once the adoption of the customer and the user generated content starts growing, um, the the token usage has exponentially has gone up. It went from millions to billions.
No.
Whereas the value to the customer is almost same.
Mm.
Okay, and in this case, when you kind of extrapolate the same 10x growth month on month, this model will suddenly become unviable
Yeah.
economically after 6 months.
Yeah.
So this pipeline, then we had to come back and say, hey, if this can happen to one use case, it can happen to any number of use cases. While we would like to detect them early in the game, but some of these things are only detected once you roll out to 1,000 customers or more, or once you hit, let's say, 5 million token size.
Mm, mm, mm.
So then we created another checkpoint in production after beta. You basically this checkpoint you again decide a business executive decision like go or no go. Should we continue in the token model or should we offload them to an in-house GPU based model, which is a lot more cost effective? So the example that I use is using an Uber is extremely convenient. But then if you have like if you are using only once in a week, then it's great. But then if you have to actually use it like in a heavy usage, then it's better that you actually purchase a car and then actually start using it. That probably become a lot more cost effective. So a token based system, API based is more like an Uber, convenient but expensive. But then GPU based is more like an owning it, but then it'll actually give you long term ROI. So that's one nuance. Second one is the know-how from engineering of the AI orientation is not natural.
Mm.
You can take a great engineer, traditional engineer, but then when the model comes in, they are not able to automatically adopt and find out the possibilities of that using that particular model. And then the amount of investment that you are actually working on. For example, to build a use case, I might want to use in a real-time case like 75% using model out of the box functionality, and then I code 25%. But most of the times engineers are actually tending to code traditional ways because that's how they have been doing it, and then under leveraging the model, and then by not actually completely pulling the value of the model itself or the LLM itself. So this is another area where we are working very closely with Microsoft and AWS to train and kind of orient our engineers to see like, hey, how do you actually see a value and benchmark and get most out of the model itself. So these are the two major ones, and there are other tooling and other issues, but these are the two major ones.
Just to double click on that part, which is like, hey, our engineers need to understand the model better, right? Is that
Yeah.
like, oh, they try out and wherever they see like there are gaps, they start coding it for that, versus you could have fine tuned or did something else to get better performance of the model? Is that the
Absolutely, absolutely. Model by default behaves in certain way, and once you fine tune it, it can behave totally different way.
yeah, yeah,
And
makes
model
sense.
with a particular use case, it can behave in certain ways, and if you change the use case, it might be totally become ineffective. But as an engineer, I have certain constraints, or time is the main thing. I need to actually
Yeah,
go to markets in next 1 month.
yeah.
So
Mm.
all I'm doing is, hey, you know what, let me actually just go ahead and code it so that end user at the end, like they don't care, end of the day, it should work, the functionality should work. But then this experimentation is actually it needs a different mindset, and that's
Yeah,
why I think some of the recommendations in the following, I think the episodes also I will have is it's important to actually build a team of a data scientist who will continuously start looking at possibilities of new LLMs that are coming in and educate the traditional engineering teams.
absolutely. I think makes amazing sense. Right now, okay, I have built a model. Now we
Yeah.
talked about cost, performance, like what time it takes. Now you have to scale it, right? Because it's about, I took it to one customer, everything looks good. You talked about like you did a beta at like 100th customer or 1,000 customer, right? Like, first of all, how do you even scale to that kind of a stuff? Because this runs on GPUs or it goes through APIs to tokens, right? What are some of the ways that you are able to scale these Gen AI applications itself?
Yeah. So scalability is again a whole different. Again, we'll have a separate episode for it, but just to give a glimpse of it, it's important for us to be able to extrapolate where this particular the traffic will go in next 12 months to 18 months upfront. So we can use some of the data, and that's why we recommend the companies to go private beta, and then you go to public beta, and then you go to general availability, right?
Yeah.
So private and public will give you enough time and runway to actually be able to understand what the model is doing in production honestly,
Yeah.
and what kind of consumption it is doing, what kind of output it is doing, are there any hallucination happening bias in production. This is when the real customers are hitting it. And during this time, it could be anywhere between 1 month to 3 months. You collect enough data to be able to extrapolate. Hey, if I have 1,000 customers and I release my private and public beta to say 50 customers, which is 5% of my user base, that will give me enough data to actually extrapolate it across 100%. And that will actually tell you if you do roll it out to 100% of your customers, where will the cost go? What kind of capacity would you need? It's also important because the GPUs. So one very important thing I noticed is cloud is a capacity promise. The reason cloud was actually born is that, hey, in data center world, you couldn't provision capacity on demand because
Yeah.
the lead times are months and years, whereas in cloud you could just go and provision. So, and this is not true for GPU. GPUs are finite, and when you need the capacity, you won't get it. And that's why it's important to work with your principal cloud partners to be able to give them the forecast and build this on the spot. So these are some of the scale challenges as you scale up. So one is use private beta, public beta, and production. So give you enough runway to be able to predict. Second, predict for next 12 to 18 months and work with your principals to actually provision that capacity and build a certain centralized platform that will help you auto scale. Don't over provision, so you are leaving money on the table. At the same time, if you under provision, you end up hitting the
Yeah.
capacity bottlenecks and dropping the packets.
Got it. Got it. So moving on to the next one, right? Like now, Gen AI solutions or systems are not in isolation, right? You need to put together with your existing set of systems. Now, when you talk about one set of things are the existing systems, the other set of that are the people and the practices behind it, right? Now, in a large scale companies and all, how do you see it evolving? Because everybody talks about Gen AI. Are people feeling left out? Like, how do you see this uh, overall ecosystem moving? Right?
Yeah. So while GenAI is super exciting and it's actually exponentially kind of improving user experience or even use cases, it is still an evolving thing, and you won't know what you need to pull off the shelf or what you need to enter the shelf. And that's why I would suggest two methods. One is build in a centralized system that will act as a broker between your traditional engineering systems and cloud, where you actually consume generative AI models from. So this broker will do the overall single API kind of a connection to the existing products and systems that you have, and you can actually start building all your governance and scale and the auto provisioning into this system, right? So that way, you are preventing your individual business units or products to innovate and duplicate the efforts of innovation on the AI. That's one. The second thing is, as we build it, there could be a scenario where um, you might want to actually pull off some of these features. So any feature that is built on generative AI on an existing product, in an existing product has say 10 different non-AI features. You build one AI feature on top of it. Build a provision such that you'll be able to turn it off when you need to,
Mhm, mhm.
without impacting the core product functionality. So, which means if for some reason the token system of generative AI goes down or the model drift happens and the functionality changes, you'll be able to shut down that feature alone and still be able to run your business as usual.
Mhm.
Rather than completely refurbishing your system to switch to generative AI, and since it's evolving system, it can go down or it can actually act differently, then you'll end up actually bringing down your whole business. So I would say a centralized system. Second thing is build it so modular that you'll be able to actually include, exclude as needed.
Got it. Got it. Amazing points. And we talked about how do you take the systems, move to thousand, like how do you continuously look at it? Because model drift can happen anytime, right? You talked about it, like you want to shut down. But how do you
Yeah.
even detect that, hey, there is something happening, and how do you continuously evolve? The new set of LLMs are coming, or maybe there are better ways to tune it, right? How do you keep track of those things?
Yeah. So so once one part of the team. So here we see three components. One is the traditional engineering teams building, um, you know, the use cases on Gen AI. Second part is the central system that I mentioned. This is a platform team or somebody who's building this platform itself, right? Which is parallelly evolving. Then there is a third team, which is actually a governance team and also the team which has oversight. And this team basically has certain metrics defined in terms of what should generic behavior of the model, what should be my generic round trips for each token that is going in and out, what should the cost, right? And all these 6 to 7 parameters, and they continuously take feedback from each use case. You can even go to unit metrics. Unit metrics are all about cost or performance per agent, per customer, per region, per product. So to that kind of granularity, and it continues to feed your system back, and then if anything that goes from green to red, then this model or this particular use case is drifting from a good ROI to probably a lower ROI. And at this point you have to take one decision: either bring it in house, the owning the car model, or deprecate it altogether and actually build it totally in a different way. So it's a continuous monitoring and improvement is also important, which is slightly unlike the traditional SaaS product.
Agreed. Agreed. Great. I think we have some questions. So let's probably take. I think I'll go to the first one. How is GenAI application working in edge computing? Is Llama on edge computer a dream?
Um, so I think it is evolving as we speak, and the while we have a huge, massive trillion parameter models, we also have very specialized models which are actually running on edge computing and even laptops or even
Yeah.
Raspberry Pis. And I would definitely, most of the companies like to claim, large companies, that hey, you won't need a smaller model when you have a large model which can do everything. But I know there are appliances, there are IoT devices which actually need like local LLMs, and I see that there will be a lot of use case for it. So it's not a dream. We will see more of this stuff happening in the future.
Got it. Next question is adopting GenAI via chatbots for Q&A and support assistant. My question is, does following this sort of business model approach requires a lot of resources in terms of manpower to computation?
So I think initially, as we continue to kind of innovate in terms of hey, the traditional SaaS way of building bots, and or individuals using automated bot functionality versus Gen AI. Initially, yes, there is a learning curve and there is a higher usage of resources, initially manpower and computation. But the way I look at it is, if we do a right investment in right places, when you look at the horizon of 1 to 2 years, the break even will happen faster. Then all these agents, the human resource requirement, this will dramatically go down.
Yep.
When we tune the model to the right extent, then you start seeing that there is a tremendous value addition, and then computation also can actually go down depending upon what model we use and how do we optimize. So are we there yet? No. I think 2024 will be still the year of additional budgets and additional spend on generative AI, but I'm hopeful that 2025 and 6, where you'll actually see some kind of break even happening for most use cases.
Nice. Perfect. And what is your opinion on model centric AI versus data centric AI?
Yeah. So I would say they will go in kind of hand in hand. Model centric would be functionality specific and based, and I think kind of it'll give you all the functionality that you need to build certain use cases. Whereas a data centric would be specific to a particular customer or a particular domain, where basically I'm inputting say 500 million different tickets of IDSM to build the knowledge base that is there ever be. So um, I would say the data specific would be more like a proprietary models, like you just mentioned, the smaller models tuned tremendously to
Yeah.
scale, whereas the model specific would be for generic use cases. And I say both will coexist for some time.
Or I think sometimes you take the generic model and then train it with the data center so that it becomes much more tuned to the stuff as well. So
Correct. For that, we need to choose a smaller model,
yeah,
especially training large models like, for example, GPT-4. It is so expensive that it can put the companies out of business.
correct. Cool. I think with that we are done with the list of questions. I think. Oh, okay. There is one more. Most of the Gen AI startups are focusing on building on the API layer of popular LLM. How much of the emphasis on the hardware side, which plays a major role, is being explored? Is the only for the big players to the likes of Nvidia and Intel?
Yeah, Intel is nowhere in the game today. Unfortunately, they were the flagship chip makers, but Nvidia is like commanding 90% of the business, and for all you may know, AMD might catch up, but that will hardware is no more commodity. It'll become a deciding factor going forward. So what the DGX framework that NVIDIA is building, the full stack, the chips, the hardware, the network, the switches, low latency and high throughput, I think will become um, the compute of future, where the footprint will go down. Because just imagine, right, the amount of cooling power, the environment impact on the GPUs is so high. So this innovation is continue to impact overall the way we are going to use GenAI. So NVIDIA will continue to rule the world and hold us for ransom. And that's why Microsoft and AWS, all these folks, kind of trying to come up with their own chipset to actually counter this. So it will continue to be important for us, the innovation on the hardware.
Awesome, Sridhar. I think we have, I think, pretty much answered all the questions. With this, I think we come to the end of the first episode. It's amazing to actually get your inputs in terms of how do you think about use case to what is it to prototype and how do you productionize. I think in the subsequent episodes, we will look at how do you scale it and then how do you govern it. Thanks a lot. Pleasure having you here.
Yeah, thanks for having me and wonderful interacting with this audience. Looking forward for the next episode.
Thank you.